Hey, Parabolas math industry, and we are going to be graphing the parabolas by hand because in the previous videos we have been graphing them on a computer, but it's sometimes a good idea to review them and understand how to graph them manually. So what we're going to be trying to do is we're going to try and graph the parabola y equals negative 3x squared plus 5. When you take a look at that equation, it's in ax squared plus bx plus c. But this time, there's no bx because there's no x in the middle of the quadratic trinomial. So, we have a ratio table, a graph, and some stuff we need to look up at. So the order vertex axis of symmetry opens up or down, or the number of x-intercepts is actually going to help us understand what the parabola will look like on the graph. So let's start. Y equals negative 3x squared plus 5. The first thing we want to do is we want to find the starting point, or the vertex. The vertex is usually where the curve is on a parabola. So since our vertex is the end, like this, the point is going to be 0, 5 as a point. Because if you look at the equation, the number 5 right there is your c value, where it's going to start. So we start at the middle. 1, 2, 3, 4, 5. That is where the curve will be. The next thing we gotta do is we gotta find the axis of symmetry. Back in the previous videos, the axis of symmetry is sort of like the center line of the parabola. It's going to be where the middle of the parabola is. If you fold the parabola in half, the right side should match the left side if you use a mirrored image. So basically, the middle point where the parabola is. So if we have a parabola, imagine there's a parabola intersecting this dot, we can understand that the axis of symmetry is going to go straight down the y-axis like this. And that is going to be an equation as x equals 0. Because that is where the center line of the parabola is. The next thing we gotta look at is if the parabola opens up or opens down. If you look back at the equation, it looks like that there's a negative in front of the coefficient of x squared, which means that it will become a parabola that will be facing down. If you have a negative expression like x squared, is going to face down. If you have a positive expression, it will face up. So in this case scenario, we're going to say that this opens down. And the last thing we gotta do is understand the number of x-intercepts. And when you look at the graph, since the parabola is going to be pointing down, and is above 0, 0 on a point on the y-axis, we can say that we can have 2 x-intercepts. It's going to be intersecting on the left side of the graph and the right side of the graph. And the x-intercept always strikes through the x-axis. So let's start making our equation and our parabola. So looking at this, we are going to have to insert some numbers to get it onto a graph. Type in the comments below what you think should be inside here. Let's see. What I'm going to be trying to do is we already know 0, 5 as a point. That is what that brown dot is there for. That is our vertex. Let's try if we insert 1 in for x, what will become y? Let's do the math below. So, we have negative 3 parentheses, 1 squared plus 5. With order of operations, we are going to use the exponents first. So 1 times 1 is 1, and negative 3 times 1 is negative 3. Plus 5, that is going to be a positive 2. So when we insert 1 into the expression, we're going to get 2 as an outcome. The same thing goes with negative 1 and positive 2. The reason why is, if you ever look at a parabola, let's say we look at this kind of parabola, we're always going to have a negative times a negative and a positive times a positive. And it will always get the exact same answer. Negative 3 times negative 3 is going to be a positive 9. And 3 times 3 equals a positive 9, which means your parabola is going to look like a U-shaped line on a graph. So, going back to the original problem, we can actually say that when we have 1 and negative 1, it will both bring us positive 2. These pairs are called corresponding. It's called corresponding when you have a positive and a negative multiply each other to get the same answer. Now, let's put it on the graph. So we have 1, positive 2, and negative 1, positive 2. Let's look for 2 more pairs. So, what would happen if we try to put the number 2 and negative 2 into them? Let's see what happens. So, we have negative 3 with parentheses, 2 squared plus 5. 2 to the power of 2 is going to be 4. So negative 3 multiply that by 4 plus 5. Negative 3 times 4 is negative 12. Plus 5 is going to equal negative 7. Not just a positive, but it will also become a negative. So we can write negative 7 right there. And negative 7 right there. Let's start graphing. So we have on the graph 2, 1, 2, negative 7. 1, 2, 3, 4, 5, 6, 7. Right around here. Then we have negative 2, 1, 2, negative 7. 1, 2, 3, 4, 5, 6, 7. So, right around here. Right around here. Since we have a lot of information from the left side on the ratio table and understand the analytics for the parabola, now we actually get to do the final strike, which is actually making the parabola. We actually get to make the parabola. So what we're going to do is we're going to start at the vertex and trace your pencil or pen and make your parabola. But make sure it strikes through all of your points. So, yeah! We have made a parabola manually by hand. When you try and graph y equals negative 3x squared plus 5, this is what it will look like on a graph. So we have did it!
Let's go! Oh yeah, Mario time!
And that is how we can graph parabolas by hand. I hope this video has helped you. Thank you for watching Tailpin Airlines Math Industry. Like and subscribe.